Now
Why
it
are
is.
we recording? Why are we recording this class?
Well, because for posterity, you want to review later what we learned, right?
But don't have to watch the.
You don't have to ever watch it again. All right, today we're going to say a few things about inverses. Mainly, we're going to remind you, again, just kind of like we've been doing along the way. We're going to remind you of things you should know from Algebra 2, and then we're also going to layer on top of it something that, some things that I think will be more challenging. I hope that that's been the thing we've been doing the last couple of days. Going a little bit deeper than what you've done before. We'll remind you first about the notion of an inverse relation. I think I just took this from the book. We have this idea that if AB is in the relation, we're not even talking about functions yet, notice. Then BA is in the inverse relation. And we'll just use that as a definition, a working definition. Already motivated in the direction that I think you already know about inverses a little bit, so you understand why we would want to define it that way. AB becomes BA in the inverse relation. Visually, we might use what test to see if we take an inverse relation, we create the inverse relation. How will we know whether that will be a function ahead of time, before we do the inverse? Yeah, Jade. Okay, yeah, I guess I'm not asking about, you're onto something, we will talk about that, but I guess I'm asking the question of will the inverse, before we ever form the inverse, how will we know that the inverse will be or will not be a function? You remember the rule there? Yeah, visually speaking. Yeah, it's like the vertical line test, only it's the horizontal line test. It should be maybe clear why that works, because you're looking for two places where you have two inputs that go with one output, right? When you do the inverse, you'll have then that will mean you'll have one input paired to two outputs, which will be a problem. Yeah.
So you conclude that even functions don't have an inverse that is a function?
There's only you could think about a very, very non-trivial function, but yeah, no, even functions don't have inverses as functions. All right, so the question is, here's your two-part question. Algebra 1 first. Is this a function? Yes, no, yes, no, yes, no, yes, no. In a few seconds here, I'll ask you to shout them out here. Down here, we're asking, if you were to take the inverse, would it be a function? Yes or no, yes, no, yes or no, yes or no. Okay, so I'll give you a second to think about them, and then I'll have everyone call them out here in a second. Good, right? Algebra 1 review, Algebra 2 review. Okay. Have you thought about it with your group members yet? We're asking why? Which is the horizontal line test. All right, you ready? Here we go. The first question is it a function or not? I'm going to ask that question about each one of these. Ready?
Yes. No. 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 Yes.
Isn't this so fun? Okay, next line. Algebra 2. Algebra 2 this time. Is the inverse of each of these a function is the question?
Yes. Yes. No. No.
Give yourselves a round of applause. That was so good. Well done. You did a good job in Algebra 1 and Algebra 2. Good job. Okay. This one's interesting to me because it's a function. And it has an inverse that's a function. That's wonderful. None of the others have that property. That makes this function, I don't know if anyone knows, a function that is a function that passes the vertical line test. And it has an inverse that's a function, passes the horizontal line test. It's called a what kind of function? 10 imaginary bonus points to Aiden in the back. That's right. And if you have if a function, we can finally define what we mean by inverse function, not just inverse relation. By inverse function, we mean we don't even have any meaning here, unless we specify that the function be 1-to-1. If, and only if it's 1-to-1, then we have an inverse function that can be defined, and we'll call that function f inverse, written this way, f inverse And of course, I think you know maybe this and use that notation, but we'll emphasize this whole domain and range part today again, right? The original function f has domain b and range r. What's the domain and range of the inverse function? Well, domain r and range d. See how, right? It's really an immediate consequence of the definition. You're going to switch all the elements of the domain range, and of course that happens, maybe. Okay. So, I think it goes without saying then that not all functions have inverses, and we've already commented on what Aiden said about what is required for f to have an inverse. It needs to be a one-to-one function. All right, in the name of giving you things that are hard, okay, I've given you a problem that is hard. Find the inverse of this function. Go. F of t equals t over t plus 1. And state the domain range.
Actually? Yeah.
I feel like that was
All right, we need a hint maybe, right? Are you getting stuck?
I am. I don't know how.
I mean, I think most of you got to here, right? You're like, I don't know, what did you write? Did you like write something like this? And then you're like, I don't know, maybe this. Okay, but then all of you got stuck. Anyone willing to give a hint? We don't want to give anything away. Don't give them all the way to the answer or something like that. Just give them like a hint or a hint and a half or something, right? Yeah, Joyce, you got a hint for us? Because we're stuck. We need your help. Okay. All right, that was like half a hint. So it was a decent hint. Distribute, I think it's like a smart move. Distribute on the left side. Keep working. We don't want to give anything away. You want to solve for what? Solve for y. Keep your eye on the prize. Yes, it is. Wait. No.
Wait a minute. I'm not completely sure. You gotta stay with me, Jasmine. I could mess up. Chances are very high stakes. Yeah,
you do after you distribute? Anyone figure out what to do? Collect like terms. What are we doing, Jasmine?
When you get x, y, x, y plus x.
Speak up. Wait, Jasmine's got important information apparently.
X, y plus x.
Okay. So we did that. We all did that, but we're still stuck.
Everyone's in the stuck like mindset that you have to leave x on one side, and then you just try to move. If you bring x, y to the other side, then you can get closer to figuring out a function.
If you bring x, y to the other side.
Yeah, instead of
Okay.
just trying to keep x
All right,
together.
let's
bring
do
y
that.
together to isolate y.
Okay, I think I'm with you.
Should we keep on going or should like?
No.
Just keep on.
Can you figure it out yet? We're remember, keep your eyes on the prize. We're trying to solve for y here. Yeah, we do get exactly what you have, which is fine. Yeah, it's good.
You can take y out of the off the right side, so it becomes y to 1 minus x.
Okay, I think I'm with you.
And then you can divide by 1 minus x both sides, and then you get y.
Is that right? All right, so I guess if we're writing it using the original notation, we'd say f inverse of t is t over 1 minus t. And it also asks for the domain and range of that. What is the domain? Yeah, t can't be 1. And what's the range? Yeah. Not equal to 0. I think.
Yeah, it can be equal to 0. If t is 0, then it can be 0.
What do you think? Do it.
This is the range, is the domain of the original function.
Oh.
Real numbers, but t can't equal multiple.
Yeah, isn't the range of this function the domain of this function? The domain of the original function is t can't be negative 1. Yeah. I guess here we should say like f inverse of c or something. Can't be negative 1. All right, that's a decent place to stop. Yeah, we're doing homework 5 tonight. Have fun. We will see you tomorrow.